We start off with Tomislav Hlupic, a consultant at Poslovna Inteligencija, a regional leader in BI solutions and implementations, where he's gaining expertise in banking and retail business intelligence systems, working in Microsoft BI stack. Tomislav will talk a bit about fast streaming architecture and the IPTV recommender system that Poslovna Inteligencija has developed. Tomislav will be joined by his colleague Iva Soric, who is also a consultant at Poslovna Inteligencija, and I would remind the audience to pose their questions through our platform. Tomislav and Iva, the floor is yours.
Thank you. First of all, we would like to thank the Institute for Contemporary Sciences for having us second year in a row. We are really proud to be speakers at this great conference. Also, we hope to be attendees as speakers in the future. And today we will present the recommendation system built for IPTV on a fast streaming architecture, which was done as a proof of concept and already implemented on several vendors' platforms. I will be talking mostly about the technical and architectural stuff, while Iva, who has developed the recommender system, will talk about the recommender system itself. We have a bit of technical issues. Maybe the button isn't working. So before we start with the presentation itself, I would like to present our company. We are the leader in the business intelligence for the Southeastern Europe region, but our focus is not only on this region, but also on the projects in Europe and in the world. We have over 200 realized projects, several ongoing projects, more than 90, I'd say maybe over 100 users in 20 different countries, over 110 employees. Most of them are consultants or implementers of the systems. We have 20 business analysts, 5 project managers. Our offices are situated in Zagreb, in Podgorica, Belgrade, in Sarajevo, and in London and in Vienna lately. Our expertise is over 600 man-years, so multiply man-days towards years, and you can see how many hours we have invested in implementing the solutions and in ourselves as the consultants gaining knowledge on the different projects. Our fields consist of analysis of the client's needs, the design of the solution, development of the solution, implementation. After the implementation, we provide the support constantly for the users. And finally, our last field of expertise is education. We have opened an educational center 2 weeks ago. We have developed our own educational track, also based on our expertise. So the agenda for the presentation is the introduction, where we will present the content delivery services, the different types of the content delivery services, also the difference between several IPTV, not the IPTV, the digital solutions used for the content streaming. Then we will present how we did the analytics system, what were the business requirements, what was the technical solution. After that, Iva will present the implementation and the development of the recommendation system, which was a part of the content analytics system developed by Poslovna Inteligencija, and they will give the conclusion of the whole system and what we have presented. So the main idea behind building the recommendation system is that the content provided by the communication operators is given to the users all the time, but we need to tailor it to the user's needs. So the operators can gather as much data as they can, even if it's based on one click that you have on your remote. And you need the system built specifically for the analysis and for collecting the data, which is growing rapidly. Imagine collecting the data from all the set-top boxes provided by some operator. You will get every click, every channel change, every volume change. Everything is collected, everything is written in the system, and afterwards it needs to be analyzed in order to provide the recommendation system the valuable data which is used to build up recommendations for every and each user. The analysis is done in the real time, so we had to develop a solution that is able to consume the data in the real time, meaning all the source systems can give the data without having some delays in the processing. So we had to develop the integration system which can provide the real-time streaming support and the batch support. By that, we gave the operators the possibility to maximize the revenue and to minimize the costs. Imagine giving the operator a possibility to minimize the cost of developing a new system or buying some TV rights by knowing what their users will actually watch. Besides that, operators can serve their customers better. So I don't know how many of you are using the IPTV, but sometimes the channels change. And users, especially the ones related to sports, are quite affected by it because different sport channels provide different content. So if you lose a channel and you didn't know your users were focused on it and were using it, you can lose those users. So besides minimizing all of that, you can minimize the churn of your users. And finally, by having tailored customer content, you can reach the highest possible level of their customer experience. So they will be all the way drawn to your system and to the content you provide for them. Therefore, the operators and the content providers need a system which will help them to give a recommendation for every user. The difference between systems when we're talking about the TV and the broadcasting is that some of the systems can give you only the real-time content. Those are the, let's say, historical systems. Nowadays they are digital, but it's the terrestrial TV, the one that you plug in into your set-top box if you don't have the connector on the TV, either you plug it directly to your TV. You have the digital satellite TV, which was used more in the 90s, but nowadays IPTV has gained much more usage. And finally, the cable TV, which is more or less stable. All of them are digitalized, but have the downside of having only the real-time streaming. Meaning once the broadcast is done, you cannot go back and watch some content you wanted to watch like 30 minutes ago. Maybe you got stuck in traffic and couldn't get home on time, and afterwards you cannot watch anything. Either you have to watch the rerun somewhere later. Also, the downside for the recommendation system is that the data cannot be bound to a particular customer. It can be done by using some sophisticated engines which are placed before the TV. which gather the data about the usage. Streaming services, on the other side, are using the internet IPTV protocols to distribute the content. By the streaming services, we mean the IPTV. So you know all the set-top boxes that you receive from your IP provider. Also the over-the-top solutions, which are gaining more and more popularity lately, and mobile TV. Consumers using the streaming services can watch both the content in real time and go back in the history without any hassle, and mostly without having to pay additional costs for it. There is a difference between IPTV and the OTT. First of all, IPTV is provided to you by the local telecom. In Croatia, there are two telecoms providing it more or less. In Serbia, probably every telecom has their own set of content. It's binded to the local network, so the router you got from your provider has a dedicated network. You cannot plug the IPTV into any port. It has usually 2 ports for the internet and 2 ports for the IPTV. The receiver is that set-top box you got, and the display device is the TV. OTT services are provided by some studios, by channels, or by independent services. So they can also be provided from the telecoms, but not necessary. The content you receive via public internet and via the local telecom, meaning the content generator is generated through the internet, distributed over internet, but is distributed to you through your local telecom operator, and the content is purchased by the consumer. And the receiver, finally, is the one that you actually use, whether it's your computer, whether it's your mobile phone, whether it's your laptop. Or it can be the TV with embedded systems. The display device is the screen provided by you, so it can be the mobile screen, the TV screen, or whichever screen you're using to display. The business requirements for the recommender system came from the providers. So the analytical system needs to provide the data and to understand the consumer's behavior, to understand which content they can consume, through which channels, and at what time and at what device, since that differentiates the usage on the mobile devices or at home. The system needs to analyze the performance of the packages. It needs to use the rating informations. It needs to segment the customers into different clusters based on their behavior. And finally, the system itself should approach the customers with the appropriate offers based on their behavior. The solution that we have built consists of the Kafka engine, which I will describe later. The storage system is Vertica. For those who don't know, Vertica is the columnar storage, which is working really, really fast. In the past, Cassandra was taken into consideration, also as a columnar storage, but just the speed and the volume of the data that was coming, Cassandra couldn't handle. Vertica also offers several different connectors, one of which we have used for connecting to the Spark engine, and for the visualization we have used the Tableau. Also, there is a custom tailored application developed by our innovations and research department. And all the recommendations are written back all into their specific tables in Vertica. The source systems are the IPTV, so the set-top boxes, the video on demand the OTT, the OTT providers. The system, the source system can also be the mobile device, meaning the content on the go. The Kafka is used for ingestion, and it can be processed in the real time or in a batch. So the Kafka cluster is put before the storage solution. The data is loaded by running a series of copy statements. Each loads the small amounts of data, so the volume is not on the highest peak at all. For the real-time streaming, it can also automatically load the data into the Vertica as it streams to the Kafka channel. The Kafka channel gets the data as a message. Usually, the data is put in a JSON or Evra format. JSON is mostly used also on the web platforms as a semi-structured data, but the custom parser can be built for any source system. So based on the system that you are using, the same integration type can be done. The feed of messages coming to Kafka is grouped to form topics, and those topics are later divided into partitions which are fed to Vertica target tables and store the data. On the business side, the recommendation system provides the real-time usage dashboards and the reports. They can be done based on the geolocation, so on the map view. You can see the trend analysis. You can drill down using the Tableau dashboards and the reports to see the different granularities of the data, and you can calculate the different metrics. The system provides the behavior of the user targeted to each user specifically. You can see the behavior through channels. You can see the behavior binded to the content. Finally, the behaviors and the usage based on the device, based on the delivery types, and based on the actions that were taken. So each action, every change of the, for example, every change of the channel gives you the different behavior type and can give you different value. Finally, putting the customer into different segments. And the business value is the predictive model for segmentation of the customers, the recommendation for the customers, and finally the cross and the upsell. And I will give the floor to Iva.
Thank you. Okay, I'll be talking a little more about the recommendations module inside of our content analytics platform. First of all, why recommender systems? This topic was already covered on the conference, so it'll be a really short introduction. The main reason is the information overload problem, which, for example, for an IPTV means that the user sits in front of a TV in the evening and he wants to watch a movie, and he doesn't want to spend an additional hour browsing through thousands of channels searching for something to watch. So he needs a little help in the information discovery. So companies use recommendation systems to solve the information overload problem, to improve customer experience, and of course, if possible, to increase revenue with potential cross-sell and upsell possibilities. So the idea is to approach consumers with special offers and personalized recommendations. And this field is not very new. There have been a lot of advantages through the years in the recommendation systems, and basically there are two types of approaches that are mostly appearing in these kinds of implementations. The first is content-based recommender systems, which basically build profile to characterize both users and items. And for example, for movies, that characteristics can be the movie genre, director, his popularity, starring actors, and so on. So these are really concrete, measurable features. While in collaborative filtering, these algorithms are more focused on the interaction with the platform. So basically, they only take into consideration the user's activities. This can be explicit ratings data, like if a user is asked to rate every movie he watched with a rating from 1 to 10, or if that information is not available, then we have their activities and their past behavioral data, like clicks, purchases, views, and so on. So the idea for collaborative filtering is to make predictions based on what other similar users liked. And these algorithms are in general more accurate in most cases, but they have a big disadvantage. That is, one of the disadvantages is the cold start problem, which means that they cannot make predictions for new users and new items since they do not have historical data about them. And there are, of course, hybrid recommender systems that combine these two approaches. And when building a recommender system for a content delivery platform, there are some additional complications that need to be taken into consideration. Like, for example, the absence of explicit ratings, which is the case in our implementation, since we do not have explicit ratings from users, since that would be probably annoying for them. So we only have their information about what they watched, when, on what device, for how long, and so on. And that is also an important information about their preferences. The other very important thing is that typically for an IPTV, one account is used in one household, which means that the user data is actually the data about a couple of different people. And then there is the thing that prices can vary over time. Maybe some items are not available at all times. Some additional business rules like filtering of adult content, and of course the performance issues, since typically recommender systems deal with large amounts of data and need to serve a large number of customers. Okay, we built a recommendation system as part of our content analytics platform, which, as Tomislav explained, uses the vertical platform in the architecture. So the source data for recommender system is also stored in the Vertica database. And basically, we used detailed activities on the users, which is records on basically every click on the remote machine. So even if he paused or changed the audio or something like that. So a lot of pre-processing of the data needed to be done to clean it and prepare it for the algorithms, and to take only the records that actually apply to the watching of the movies and the shows. And basically, the two tables that we derived from this detailed data look something like this. But for the on the right corner, the user item interaction table doesn't have explicit ratings, but derived implicit ratings that I will explain a little later. And the other is items metadata, which it contains information that we have about the movies. And these two tables are refreshed and maintained on daily basis. Our chosen approach uses collaborative filtering, model-based collaborative filtering, where users and items are represented by a set of latent factors or features that are derived from the patterns in the watching in the users watching the movies. So these are not necessarily humanly interpretable features like the movie genre, that are just dimensions used to make to estimate the user's unknown preferences. And to learn these factors, matrix factorization techniques are used. And the tools and techniques we used include Spark, Apache Spark, which is a big data tool, a parallel processing engine that fits in our big data architecture. We used the Spark machine learning library in Python, so PySpark. And since the source data is in Vertica, we used a Spark Vertica connector to communicate between those two. The connector allows us to, in a simple manner, read the data from a vertical table in Spark, RDDs, or data frames, and the other way around to save the calculated results back from Spark in a vertical table. And Spark's implementation of collaborative filtering uses alternating least squares to learn the latent factors. And the thing about Spark's implementation is that since ALS calculates these features independently of others, it can leverage parallelization for better performance on large data sets. As I mentioned, we don't have explicit ratings, so we calculated some kind of implicit estimated preferences. We basically use the percentage of the show that the user actually watched as some kind of estimation of his preference for that show. So we derived the implicit ratings by this simple formula. The highest rating is 5 if the user watched the entire show, and the smallest rating if he watched it is 2, which means that he at least started to watch it, so it means he at least showed some kind of interest for it. And the more he watches, the greater the level of confidence in his estimated preference. Okay, and the results are stored, calculated in Spark. The calculation is scheduled on a daily basis during low activity periods, like during the early morning or night. And the results are stored back in Vertica as top 10 recommendations for every user. The idea is to integrate the IPTV platform with the results to serve the customers with top 10 recommendations while they are watching something, while they are searching for something to watch. And because of the cold start problem, we also save and maintain a table with the most popular items to show to new users. So in conclusion, we realized the importance of recommendation system and their role in customer experience for content delivery platforms. So we developed content analytics systems for content delivery services that has 2 main features. One is the part that Tomislav explained in the first part of the presentation, the processing of structured and unstructured data from the content delivery platform. And the other is the content analytics module, which includes the recommendation system. So that would be all. If you have any questions.
Thank you. We received 7 questions so far. Question number 1, how do you recommend something when multiple users watch using the same top box? You mentioned that earlier. So how do you measure that?
You mean
data?
when there are a couple of people
yeah.
using the same set of box?
The household.
We are currently not dealing with that problem, but we are planning on taking that into consideration in the future. Basically, the idea is to look at the times. We are assuming that maybe if it's a family, maybe the parents are watching the TV at night, and maybe the child is watching in the morning, so we would look at the time to take that into consideration.
I will go straight with the connected question. How do you handle GDPR consents, having in mind that one receiver is used by multiple users?
Are we handling GDPR? Of course we are. I honestly do not know. I have anonymized data for my algorithms. So.
Which language you used for Kafka and Spark? Why Vertica over Cassandra or some other NoSQL technology?
For Spark, I used Python. So for Vertica.
For Kafka,
and Kafka.
I think it was Java.
Yeah, Java.
Java for Kafka and
Java.
Python for Spark. You mentioned that Cassandra couldn't handle writes. Could you elaborate? Since Cassandra is the fastest NoSQL database for writes, every node can handle every operation.
It depends on the scalability. At the time of the development, Cassandra, in theory, was the fastest one. But in reality, when the data was stored to Cassandra, there were bottlenecks. Even though the data can be placed into the Cassandra cluster. Having a small number of clusters came to be the biggest problem. So it can be fast, but you need to, for the Cassandra, you need to scale it really to the high level in order to compete with Vertica.
Christos asks, what types of programs are the most difficult to predict accurately and why? On the other hand, what programs are the easy ones to predict?
What programs? Well, I don't know about programs, but I guess the easiest to predict people that are the easiest to predict for are the ones that have a specific taste, like they only watch comedies or thrillers or SF or something like that. So I guess.
What are performances between Scala and Spark?
Spark supports both Scala and Python, so it doesn't really matter. I think there are some marginal cases where Scala is faster, but I think in this case it really doesn't matter. You can use the language you know better.
What is the size of the data set and why do you need Spark?
I mean, we don't necessarily need it. We wanted to build a big data, we wanted to use big data tools and have an architecture that is scalable. So in case we have a requirement and the data set gets even bigger, we can scale it, which Spark can. You can just add new nodes. The data set includes, I think, a couple of 100,000 users and their daily data, which is every click, every action they take. So it is big data.
That will be all. Thank you very much. On behalf of the organizers, I would like to give you the certificates. Thank you for contributing to the Data Science Conference.